Hi, I'm Adina.
Hi, I'm Chun, and today we'll be talking about spatial analysis and metrics advisor.
For the first part of this session, we are going to focus on spatial analysis, a new feature of the computer vision service.
And I'll be talking about metrics advisor, a new cognitive service for metrics monitoring and root cause analysis.
Great, let's get started with spatial analysis, which enables you to draw AI insights from the real world. Computer vision is an Azure cognitive service which runs vision AI on images. Spatial analysis is a new feature of the computer vision service, and it runs vision AI on live and recorded streams to understand people's movement in physical space. Spatial analysis ships at the edge as a Docker container, and it is optimal for data control, privacy, and network-intensive workloads. Thus, spatial analysis brings to you the power of the intelligent edge, and it enables you to build powerful business applications at scale in the Azure cloud. Let's look at the three scenarios in which we can use spatial analysis: people counting, social distancing, and entry-exit of spaces. Let's talk about people counting. You can count people in a designated area, you can monitor and alert for maximum occupancy, and you can collect historical data to make decisions for how to optimize the occupancy of physical spaces. This is a demo video that shows how spatial analysis can detect and understand people's movement in a store. In this case, the AI insights generated by the container, it's a periodic people count. In this case, we have 6 people in the camera field of view. Notice that even when the people are partially occluded, the AI model accuracy is not impacted. The occluded people are still counted. For people counting, let me show you the configuration that you need to create and the structure of the AI Insight JSON that will be emitted by the container. First, you need to configure the polygon in the camera field of view in which you are counting people. You can configure the polygon to be the entire frame. Give the polygon a friendly name, in this case we call it storefront camera, and indicate the frequency at which you need the events. The field threshold indicates the AI confidence at which the events are emitted. Any events with confidence less than the threshold are going to be suppressed. To the right, we have a sample JSON for the AI Insight events emitted by the container. The type of event is person count event. Notice that we provide the friendly name of the polygon, the same way you set it in the configuration, in this case storefront camera, and we provide the person count, in this case 3. For each person, we also provide the rectangle of where in the frame the person has been detected. It is not fully shown here. The second use case is something that is top of mind these days, that is social distancing. With spatial analysis, you can set a minimum required distance between people, and you can warn of failure to maintain distance. By saving these AI insights, you can create historic reports and determine trends in pandemic compliance. This is the same video footage for the store. In this case, instead of people counting, we are running the social distancing operation. Notice that with a single camera, you may run multiple operations simultaneously. For the purpose of these demos, we did run people counting and social distancing on the same video feed. Let's look at the configuration for social distancing. In this case, you can still configure a polygon in which we apply the operation, and additionally, you provide the minimum and maximum distance threshold in feet. In our sample, we set the minimum to 6 feet. To the right, the AI Insight JSON sample indicates the event type, in this case person distance event, the event name, which is too close, and the distance violation person count, in this case 2. In other words, 2 people are closer to each other than the minimum distance threshold of 6 feet. The total count of people detected is also provided. The third use case is about people entering and exiting physical spaces. You can monitor entryways for traffic and maintain optimal occupancy. You can detect when people enter or leave a zone or cross a line, and you can calculate the time people spend in an area for dwell time and loitering. In this demo video, you can see how you can determine the wait time at a checkout queue. We draw a polygon around the checkout stand, and as people enter the polygon, we start the timer and then stop the timer when the person exits the polygon. By looking at the timestamps of the events, we determine the time spent by a person at the checkout counter. Let's look at the configuration for the entry-exit operations. For the person crossing in and out of a polygon, you have to configure the polygon, give it a name, in this case lobby camera, and you have to configure the type of event you require. In this case is zone crossing. The edges of the polygon are numbered in the order you list the vertices. That enables us to provide information about the number of the side of the polygon which is being crossed by a person. To the right, notice the sample for the AI Insight JSON, which indicates in this case that the person has exited the polygon, and the side of the polygon that they crossed. In this case, this is the third side. Additionally, we have the person crossing a directional line operation. Instead of a polygon, you configure a line or more, and the container is going to emit events when a person crosses a line. To the right, notice the status field in the JSON sample, which is cross right. That indicates that the person crossed the line from left to the right, or in other words, from west to east. Again, the line is directional, and this is best used for cameras located at doorways, where you can determine when a person leaves or enters through the doors. Now that we have explored the use cases, let's see how customers are using spatial analysis. We are partnering with NEC Technologies India to integrate spatial analysis into NEC's video analytics platform to enable pandemic compliance back-to-work scenarios. NEC's video analytics platform is enabling customers to quickly adapt to the changing COVID-19 landscape, allowing their customers to ensure social distancing and follow occupancy guidelines throughout their facilities. In the retail industry, retailers need to better understand how customers move through the store and how to modify the store layout. They want to measure how much time people spend in line or in front of a retail display, or if the store layout helps people maintain social distance. With spatial analysis, you can build your own solution for the retail industry to improve customer satisfaction, protect safety and health, and increase revenue. Spatial analysis effectively scales for business applications, and it is also available through Dynamics Connected Stores SaaS offering. In manufacturing, plants need to monitor zones where people's presence is not recommended due to safety concerns. With spatial analysis, AI running on video from cameras can detect people in forbidden zones in real time. Both safety personnel as well as the employees involved can be notified on the potential danger by alerting features. Safety personnel can monitor incidents happening over time by storing the AI insights and building meaningful reports. Now let's look at how you can deploy the spatial analysis container. First, you need an edge device with NVIDIA T4 GPU. We have tested spatial analysis on Azure Stack Edge with 2 GPU units, and you can order an Azure Stack Edge device from the Azure portal to deploy on your own premises. You may use another edge device as long as it has at least an NVIDIA T4 GPU. You can deploy spatial analysis with Azure IoT Hub. You need to create an instance of IoT Hub service and register the edge device. Then, with the deployment manifest, you may deploy the spatial analysis container as an IoT module. For the camera devices, you need to install this in your physical space following the manufacturer's instructions. And since these cameras are IP connected, you need to make sure the edge device can connect to these cameras over the RTSP protocol. Once the spatial analysis container is configured with the camera's RTSP URL, the AI insights about people's movement will be sent to Azure IoT Hub as telemetry. From IoT Hub, you may create various routes to other Azure services and build your own business solution. Let's see this in action with a demo. This is a demo that illustrates how you can deploy the container for spatial analysis. First, you need to go to aka.ms csgate to fill in the application for gated services. This is where you provide information about your company, your use case, and your subscription ID. Microsoft will review your application, and upon approval, you will be notified in email with information for how to access the container. The next step is to create a computer vision resource on Azure Portal using the subscription you provided in the application for gated services. You fill in your subscription information, select the S1 tier, and click Create. For this public preview, the usage of this resource is free. And there we go, the resource is created. At this point, we copy the API key and building endpoint values. We will need this later on when we have to configure the container deployment. Next, on the Azure portal, we have an Azure IoT Hub service that we already deployed and an edge device, in this case an Azure Stack Edge, which we already configured and connected. To deploy the spatial analysis container on the edge device, we recommend using a deployment manifest file. Here is an example. Here in VS Code, we can see a sample of a deployment manifest JSON. You can see the path to the container image, in this case pointing to the Microsoft Container Registry, where the spatial analysis container is published. We have here the create options for the container, as well as the environment variables. Notice here at the very bottom the billing endpoint and the API key, where you need to copy the values from the computer vision resource created a bit earlier. Down below, we have the person count configuration for a single camera. Notice the operation ID is set to spatial analysis person count. You need to fill in the video source URL with the IP address for your camera. You need to select on which GPU you are running this operation, and you need to provide the zone configuration for the polygon, as well as the desired confidence level. A sample deployment manifest is available for you to download at docs.microsoft.com. Look for the computer vision documentation page. In the deployment manifest, we saw the polygon field, which represents the area in which we count people. To select the relative coordinates of the vertices of the polygon, we follow the camera manufacturer instructions to collect a frame, and in this case, we are using our old friend Paint to draw the polygon. Then we calculate the relative coordinates of the vertices by taking the absolute XY values and dividing this to the horizontal and vertical size of the frame. Back to VS Code, we are ready to deploy the container. Notice the left pane where we connect it to the IoT Hub and the edge device. We'll select the deployment manifest. There we go. And we will deploy. Success. Now let's look at the modules. And we can see the spatial analysis container is up and running. Before we see people count in action, let's look at the AI Insight JSON events, which are passed as telemetry to the IoT Hub. We are going to start monitoring the built-in event endpoint. And we are seeing the events passing through. Let's search for person count. And there we go. Here we have the JSON event for person count event, where the person count is 8. Okay, the container is deployed and it is processing the video. Here we have a sample web application that shows the count of people in real time. You can see on the bottom left the video as being processed with the rectangles around detected people and the depiction of the polygon representing a zone. On top left is the video recording that you may choose to collect running in Azure Media Player. The video is available in your own Azure Blob Storage instance. Microsoft doesn't collect or use your videos for AI training purposes. This sample application is available for you to download and further modify. Visit the computer vision documentation page for details at aka.ms spatial analysis. We hope this demo will help you and inspire you to build your own business applications. Thank you. By now we've learned that spatial analysis includes AI models that detect and track people's movement. Responsible use of AI is a top priority for Microsoft. Microsoft is releasing spatial analysis together with responsible AI recommendations grounded in user and societal research. Microsoft used many of its responsible innovation techniques to develop and test these features to ensure the technology maximizes personal privacy, provides transparency, and promotes trust. Microsoft developed responsible AI recommendations in collaboration with private preview customers to guide the use of spatial analysis for COVID-19 public health and safety scenarios in accordance with Microsoft responsible AI principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and human accountability. Microsoft's principal approach enables developers to build rich solutions while upholding human dignity and the needs of everyone impacted by the technology. Visit us online to learn more about responsible AI. Thank you, and back to you, Chun.
Thanks, Adina. Now let's dive into Metrics Advisor. First of all, I'm excited to announce the preview of Metrics Advisor, an AI analytics service that proactively monitors metrics and diagnoses issues. Imagine you run a global business that has factories producing rockets and toys, of course, and you sell them on your own e-commerce website. The health of the business lies in the financial metrics as well as KPIs such as user activity indicators of the website. Your IT operations team that manages the website could benefit from warning ahead of IT system failures and root causing during service outages. The production lines could become more stable when failures are warned about ahead of time, with specifics about which precise part is about to fail. Driven by data, the common challenge across those three business scenarios is really how you could monitor the metrics data the time series. Metrics Advisor, a new platform as a service, provides you an out-of-the-box intelligent metrics monitoring platform. It simplifies the monitoring lifecycle with a built-in web-based workspace where you can set up time series monitoring, alerting, and diagnostics with simple user interface. A rich set of REST APIs and SDK libraries support developers to build your custom solutions easily. Because Metrics Advisor has built an end-to-end monitoring pipeline, time to value is accelerated. And the pipeline starts with abundant database connectors and pre-processing of your time series data by cleaning, aggregating, and filling in gaps for a consistent time series flow. Built on Cognitive Services Anomaly Detector, the core engine for time series anomaly detection, Metrics Advisor looks at each dataset and automatically selects the best algorithm from the model pool for high accuracy. Incidents trigger alerts through emails, webhooks, and Azure DevOps. With dimension tree and metrics graph, Metrics Advisor quickly shows you the key drivers of the problem. And Metrics Advisor is intelligent, scalable, and can be implemented in a simple manner. So just how applicable is Metrics Advisor? Customers such as Nash are already experiencing the power of Metrics Advisor and the benefits it brings to their business. Nash, Portugal's biggest communications and entertainment group, is running POC with Metrics Advisor. The evaluation shows that Metrics Advisor is able to monitor and escalate potential failures on customers' internet devices in time, so that automation steps could be triggered to avoid true failures. Nash is testing the use of Metrics Advisor to live telemetry data to reduce customer calls and to improve customer satisfaction. Let's look at another industry example, Flowy. Flowy is the first digital bank completely built on Azure. Flowy is using Metrics Advisor to monitor their iOS and Android apps to protect their end-user experience and ensure it runs seamlessly. With Metrics Advisor, anomalies are being detected and diagnosed quickly. The Flowy IDOps team saves time that can be spent on more crucial items thanks to the precise alerting and root cause analysis provided by Metrics Advisor. Finally, a customer with predictive maintenance scenario is also running POC with Metrics Advisor. Renault DP World F1 team has brought their first use case of analyzing data from wind tunnel sensors. The initial use case has shown promising results. Issues like noise, flatline, and inconsistency in signals are detected. The alerting enables engineers to focus on fixing the issues rather than monitoring data on the screen. So now that we've looked at some prominent industry use cases, let's dive into a Metrics Advisor demo. Meet Sam, who manages the IT department of your toy rocket company. Sam's team owns the infrastructure of the e-commerce website. Thousands of VMs and container instances enable hundreds of application components to support the traffic from global consumers. Tons of telemetries are captured and streaming at tremendous scale into a time series database. On the other front, as a data-driven company, your business-critical metrics such as revenue, daily active users are captured daily and stored in a relational database. The challenge for Sam is, if something goes wrong with an application component and leads to DAU drop, can the team be notified in time? Can they quickly pinpoint the unhealthy component? Previously, Sam's team has tried hard thresholds with all those metrics, but eventually gave up, as it ends up in alarm fatigue. Now, Sam is using Metrics Advisor to address the challenge. Like all Azure services, Sam first goes to Azure to create a Metrics Advisor resource. Then he goes to the portal of Metrics Advisor. From there, he selects his instance of Metrics Advisor web-based workspace and jumps into it. Now Sam's going to onboard the time series data for both the business metrics and the IT telemetries. For business metrics, daily active user, set the correct source type, granularity, and start time, as well as the connection information and the query. Then set the right schema and a few additional configurations before submitting the data feed. Note that the channel column and the region column are set as dimensions, as that could enable the platform to monitor the DAU from all different region channel combinations and diagnose easily when there is an issue. An aggregation rule is also specified so that Metrics Advisor will roll up the two dimensions automatically and monitor the DAU from aggregated channels and regions. For IT metrics, Sam has created a different data feed that connects to an InfluxDB, and this time, the dimension becomes different types, such that all types of telemetries are monitored under the same data feed. And such telemetry data doesn't roll up using sum anymore, as they don't add to each other. Next is to tune the models to ensure they detect anomalies as expected. The knowledge of what values of the parameters are working with the data come from the proof of concept stage before this. During that stage, Sam's team has run some validation with two small but representative datasets and got the best parameter value that works with the sample dataset for the best trade-off between precision and recall. They apply those two sets of configurations to the production data and are ready to further fine-tune the parameters in case the production data results deviate from the POC results. With that, Sam could set the alerting on instance, which enables email alerts for both business data anomalies as well as IT data anomalies. And here comes my favorite part. In order to best root cause issues, Sam could build a simple matrix graph to describe the dependencies between the system components, and more interestingly, between the system components and the business metrics. What he did was to simply depict the dependencies between different time series based on his knowledge of the system architecture and his knowledge of what really contributes directly to the business metrics. For example, DAU is dependent on latency of the front door web app, which is dependent on the database throughput, which is dependent on disk I/O and the CPU. Now it's all set. Let's give it a go and see what it can do. On August the 11th, the business manager Joe received an alert that DAU has dropped. Joe checked the incident diagnosed tree and found that the overall DAU job was mainly in the region of USA. Sam looked into the incident and found that when the DAU went wrong, the latency of the front-door web app also got anomalous, showing as red in this cross-matrix analysis graph. And further following the dependency chain has led to the DB throughput, but not the disk I/O or CPU. And Sam's team was then quite sure that the root cause lied in the database part. So they spent an hour or so checking the code updates related to the database before August 11th, and quickly found a regression in database query that has caused the issue. In less than 90 minutes, with Metrics Advisor, Sam's team managed to fix the issue, which would otherwise have taken them an entire day to root cause. In the meanwhile, Joe was able to send a service downgrade notice to their North America customers on the website, enclosed with a service recovery note. Joe was super grateful for Sam's quick turnaround, and actually, Sam went above and beyond what Joe knew. With Metrics Advisor, Sam also receives other alerts from the infrastructure data. Sam's team had taken preventive actions to those infrastructural incidents before they make serious impact to business. Now this is definitely making Joe's life much easier. Metrics Advisor also gives Sam's team actionable alerts such that they are not swamped with false alarms. And all that turns into the stability of the IT system and the growth of the toy rocket business. Today, Sam is looking to customize the platform to connect deeply with their other tools. Luckily, Metrics Advisor has brought with its web UI a rich set of REST APIs. Microsoft is also soon to roll out SDK libraries for 4 languages: Java, JavaScript, .NET, and Python, that can make coding with the service much easier. Today, more than 300 teams are using Metrics Advisor inside Microsoft. I'm excited to bring it to you. Join the preview of this service at aka.ms/metricsadvisor.
And learn more about spatial analysis, submit your use case, and review the responsible AI guidance. Thank you.
Thank you.